In this talk, I'll be presenting a large-scale, longitudinal analysis of missing label accessibility failures within Android apps. My name is Raymond and my collaborators are Mingyuan Zhong, Annie Ross, James Fogarty, and Jacob Wobbrock. Individuals who are blind or low vision often use assistive services to interact with their mobile applications. One assistive service that is commonly used is a screen reader, such as TalkBack on Android devices. Screen readers rely on accessibility metadata, such as content labels, that are provided by app developers. When developers fail to properly implement these labels, a screen reader would only read aloud unlabeled button. In this analysis, we focus on assessing how well content labeling is implemented within currently popular Android apps. Over the past few years, studies on app accessibility have largely examined the app ecosystem at single points in time. But these individual analyses don't provide a holistic understanding of how app accessibility is really changing over time. To provide some insight into this problem, we perform monthly audits of label-based app accessibility for a fixed set of mobile apps over a period of 16 months. We chose apps for our analysis by taking a sample over 31 app categories in the Play Store, selecting the most downloaded apps from each category. We then filtered apps that did not clearly expose a view hierarchy, which was required for both the automated data collection and accessibility evaluation processes. After filtering, we had a resulting collection of 312 Android apps, over which we performed monthly evaluations from December 2019 to March 2021. We developed a custom crawler to collect a dataset of screens from these Android apps, including the elements within each screen and the accessibility metadata associated with each element. We performed a modified depth-first search in which we attempted to explore all actionable elements within an app screen. For example, in this image, the crawler instructs the device to click the back button, navigating to a new screen. For each app, we then continue this crawling process for up to 2 hours, or until all discovered actionable elements had been taken. We then store this resulting crawl graph from the exploration process and then perform a post hoc evaluation of accessibility for every element within each discovered state. One of several challenges that arise when performing a longitudinal evaluation of mobile apps is defining equivalent elements within a single screen, across multiple screens in an app, and between screens across crawls. To address this, we introduce a heuristic in which we define two interface elements as equivalent if they have the same view ID resource name and class name properties. This flexible definition supports tracking repeated items within a screen and also tracing elements within one app screen across multiple different crawls, even when other elements on the screen had changed. We store our crawls within a public dataset that we release to support further analyses of accessibility that are not included in this current work. On average, in our dataset, apps had about 80 unique screens and had about 20 unique elements per screen. And so we'll start with a few qualitative examples that demonstrate patterns we observed and how labeling accessibility changed over time. And for each app, we generated these failure plots, such as the one shown on the screen here. An orange square indicates a missing label, and a blue dot indicates a properly labeled element. Here we see the Zillow home buying app, and we see that there are 7 elements missing labels before June 2020. And after June 2020, 6 of the 7 previously unlabeled elements were now given labels. We classify this behavior as a systematic repair or improvement of accessibility by the app's developers. Another pattern that we saw was opportunistic improvements to accessibility. Here we see the Fox Now app with 6 unlabeled elements in January of 2020. By March of 2020, 4 of the elements had been given appropriate labels. These 4 elements were part of the navigation bar at the bottom and were likely part of a one-off effort by a developer providing labels to that component of the app. Meanwhile, 2 other elements on the screen were left unlabeled. This is indicative of a non-systematic or opportunistic accessibility repair, since reports generated by something like a semi-automated scan of the screen would have likely identified all inaccessible elements. However, improvements were not the only type of evolution in accessibility over time. This third example here shows how some apps also demonstrated regressions in accessibility. In the top image, the Amazon Prime Video app had 2 buttons properly labeled in 1 month, but in the bottom image, the same buttons were found unlabeled in the next month. We also performed several quantitative analyses, which I'll summarize here. First, do different apps exhibit similar levels of label-based accessibility? What does this distribution with respect to their failure rates look like? Generally, we observed a bimodal distribution, echoing similar results from prior studies, finding that many apps had few unlabeled elements and many other apps had most of their elements unlabeled. But with so many inaccessible apps, one assumption that might be made is that developers tend to perhaps improve the app's accessibility over time gradually. Hence we asked, did we observe any accessibility changes over time? At a high level, we saw no significant changes in accessibility at a macroscopic app ecosystem level. Another assumption that is often made is that apps become more accessible as they become more popular. Hence we ask, are more popular apps more accessible? And we found that the most downloaded apps, those with more than 500 million downloads, had significantly fewer missing label failures than apps with less than 500 million downloads. However, there was no significant difference observed between apps that were slightly less popular with less than 500 million downloads, perhaps around 50 or 100 million downloads. Many of these most downloaded apps actually came from several large software organizations. So we ask, do large and established software organizations actually publish consistently accessible apps? And an analysis of 6 large software organizations with multiple apps from each one showed that while some do publish consistently more accessible apps, apps from other large organizations tend to vary actually in their levels of label-based accessibility. And so based on our analyses, we see several opportunities to support developers in creating more accessible mobile apps. First, our data suggests that missing labels remains a prevalent problem, and furthermore, that these systematic improvements to accessibility of these apps by developers is in fact a possibility, as observed in some of our previous examples of opportunistic and systematic repairs. But it's not occurring frequently enough to improve the overall accessibility of the ecosystem. Our analysis thus motivates the need for supporting more guidelines for developers in systematically evaluating and improving labeling across their entire app. Second, our data showed some instances of code duplication, providing inconsistent labeling of elements within an app, suggesting opportunities for app frameworks and development platforms to work towards methods for reducing these failures introduced through code duplication. Finally, we believe that labeling accessibility will improve with the adoption of app accessibility best practices throughout the entire app development lifecycle. For instance, one might consider integrating testing frameworks within developer IDEs, using pre-launch reports that check for accessibility issues before publishing an app into a marketplace, and then finally using post-launch tools such as accessibility scanners to monitor and repair the accessibility of apps after they've been released. And so again, we encourage everyone to check out our paper for more details on the dataset and the analyses that were conducted here, and we thank you for listening.